Hey, this is the video for 4.4, Covalent Compounds. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing molecule, diatomic and Hofbrinkel, and Lewis structure. So a molecule, simply put, it's an element or a compound with covalent bonds. So every compound is not necessarily a molecule, and every molecule is not necessarily a compound. What? Well, basically what you need to know, if it's a molecule, it has covalent bonds. If it's a compound, it can have covalent or ionic bonds. Okay, and if it's an element, it can either have no bonds, metallic bonds, or covalent bonds, right? It's a little crazy, right? Anyway, this is something, it's just terminology that you're just going to get used to. So Hofbrinkel, simply put, it's the diatomic elements. So hydrogen does not exist as H in nature. All of these exist in their diatomic form: H2, O2, F2, Br2, I2, N2, Cl2. Hofbrinkel. Also, I just want to point out, because of this font, it doesn't have a lowercase, so Br, it should really be a lowercase r. I'm aware of that. All right, diatomic elements, Hofbrinkel. Now, Lewis structures, it's basically when you use the sticks and the dots to draw what the molecules look like. And I'm going to show you the steps. I guarantee you definitely want to write these steps down. Follow these steps. This is another thing that students really struggle with: when to do a Lewis structure and when not to do a Lewis structure. You only do a Lewis structure when it comes to covalently bonded compounds. Covalently bonded molecules. Now, here's an example. We have water. So the first step, what you should do is write the electron dot diagram for all atoms. Now, sometimes when you're writing it, you can also just combine steps 1 and 2. This is easy because I'm just using this digitally, but you should arrange the single element in the center. I always like to tell students, pretend it's a Christmas tree and you got your presents around it. Okay, so we have the O in the center and we have the H's around. Now you're going to see these single dots. The single dots will form a bond. So just using a line, connect the dots. But you're not done. This looks messy. You definitely want to make it look neat with lines. Remember, each one of these lines represents 2 electrons, 1 and 2. So you could do it with dots, you could do it with lines. I encourage you to do it with lines. It saves a lot of time. Here's another example. Carbon dioxide. So this one's a little bit more tricky. There's a limited number of molecular substances that you will have to draw Lewis structures for. So I'm only showing you 2 examples, and we'll be doing some in class. So again, the electron dot diagrams for each one is based on the valence electrons. Now we're going to arrange the single element in the center. Carbon is the one by itself. The oxygens are going to be around it. Now, if you notice, I got these single dots that are going to connect. I have 2 dots here and 2 dots here and 4 dots there. Well, do the math, connect your lines. This looks really, really messy. And what I want to do is make it look neat. So here I gotta have 2 lines, and between this carbon and this oxygen, I want 2 lines. But now I got these dots in the middle. So when you redraw it, you want to rearrange these dots so the dots are on the outside. So this is actually a double bond, and that means that there are 1, 2, 3, 4 electrons shared between this carbon and this oxygen. And we have 1, 2, 3, 4 electrons shared between this carbon and this oxygen. So we have 1, 2, 3, 4, 5, 6, 7, 8. This oxygen has its octet. Carbon, 1, 2, 3, 4, 5, 6, 7, 8. This carbon has its octet. And finally, just like the other oxygen, 1, 2, 3, 4, 5, 6, 7, 8 octet. Now, I would like you to respond to this check for understanding. I went over this fast, but I hope that this information was informative. I thank you for your attention, and I will see you soon.